All right, we're doing the second part of our pre-calculus review. We're going to start on number 10. So what I'd like you guys to do is I would like you to carefully type this. You don't have to write everything down in your journal. Let me highlight what you probably want to write down in your journal. You probably want to write down the equation. You probably want to write down that we're talking about average speed, and we're dealing with from 1 to 3 seconds. Okay? So basically, we're finding the slope of what's called the secant line, and you're going to do f of x2 minus f of x1 all over x2 minus x1. And your interval that you're doing it is from 1 to 3. The 1 is your x1, the 3 is your x2. So this is what I want you guys to write down. Don't write down everything. Just write down the equation. You're finding the average speed, and it's going from 1 to 3 seconds. First thing, let's type this in the graphing calculator. Y equals, I believe it's negative 16. It says t squared, but I'm going to use x squared right there. Then it has plus 92t, plus 92t, but instead of a t, I'm going to put an x. And then it says plus 3.5, plus 3.5. So you type that in, you check your table, okay? Check your table. We're going to check right here where x is 1, okay? We're also going to check where x is 3. So remember these two numbers, all right? 135.5, 79.5. 135.5, 79.5. So we're going to go down here, all right? And when x was a 3, what was f of x2? What was that? That was 135.5. Okay. When x was a 1, what was the first one? 79.5? Is that correct? All right. So here's what we're going to do. You're going to take 135.5, which is f of x2. You're going to take away 79.5, which is f of x1. And you're going to divide that by 3 minus 1, which is 2. So that's all you need to do. Do 135.5 minus 79.5, divide it by 2. 35.5 minus 79.5. Enter. And what we got to do, take that and divide that by 2. What do you get? You get an average rate of what? 28. Okay? So remember, this was what? This was your f of x1. This was your f of x2. This is your x1. This is your x2. All right? So your answer would be G. The average rate is 28 feet per second. 28 feet per second. Okay. Given this function, so I'm going to highlight the function that you want. Given this function right here, you have to evaluate it when x is a negative 12.25. I'm going to put y equals negative 2. Now in the graphing calculator, this symbol is the greatest integer function. So in the graphing calculator, you're going to be looking for the symbol that says integer. And you're going to type in x minus 1.5, and you're going to close the parentheses. So that's what you're going to do in the graphing calculator. All right? Because what we're doing is we're taking this right here and you're plugging it in for x. All right? So right now, go to your graphing calculator, hit y equals. All right? You're going to type in negative, is it -2?
Yes.
All right, hit the math button. Go to the right where it says number. Go down to number 5. We're going to type in an x. And we're taking away what? We're taking away
1.5.
1.5.
No.
Now, this is the greatest integer function. If you were to graph it, this is what it would look like. There it goes. Now, it's going right here. It's kind of hard to interpret the graph, but we want to actually evaluate the graph. So second window, we want to evaluate it at what number? Negative 12.25. So just type in negative 12.25. When you type it in, exactly as that appears right there, go to your table, and what does it let you know that your y value is at a negative 12.25? What's your y value? 20. So the answer is D. Now, let's say you don't do the y equals. You could still go to your calculator, and you could say -2, all right? Hit the math button, go to the right, go down to number 5, and then type in negative 12.25 minus a 1.5, and you're still using the same equation. Press enter. Alright? So when you plug this in. Now you gotta be careful because this right here, this is, remember, this answer will always be an integer because it's looking for the y value. What's the y value? What's the greatest integer of the y value when this is a negative 12.25? Alright, we're moving on. Here we go.
It's going to kill me. Look like kill me.
Alright, everybody, I'm going to zoom out just a little bit so we can see all of number 12.
What happens if you first?
Alright, hold on. Which results in the graph where the square root of x is being compressed horizontally? So right here, we're going to talk about what does it mean to be compressed horizontally by a factor of 2. Alright? Expanded vertically and reflected across the y-axis. So there's 3 things, okay? 3 things. I'm going to do it in 3 different colors. We're going to talk about compressed horizontally. Alright? Then we're going to talk about expanded vertically. And I'll write down what each of these are, okay? You guys write this down. And last but not least, reflected. Yeah, put reflected y-axis for sure. Okay. All right. So right now, let's just say the original function was f of x equals x. Okay, and compressed horizontally is by a factor of 2. Okay. By 2. All right. So here we go. Right now, if you have f of x, compressed horizontally is going to be f of a x. So put f of a x. I better change the color. Where a is the factor. So this is going to be f of a. Why don't we change it to the right color, Mr. Dude? Okay, we'll change it to the right color. There you go. Third time's a charm. F of a times x, okay, where a is going to be greater than 1. So the first thing I'm going to write is this. This is going to be f of 2x. Now expanded vertically, it's going to be a times f of x. All right. So we're looking for a number where it says expanded vertically, where a is also greater than the number 1. That's what expanded vertically means. A is going to be on the outside, not on the inside. So here, I'm going to put 3 parentheses f of x. I got 3 because I can see the numbers right here. All right? So then what's the numbers on the outside? It's either going to be a 2 or a 3. Well, since it says it's compressed horizontally by a factor of 2, where do I know 2 is going to be? It's going to be next to the x on the inside, not on the outside. So I chose a 2 and then I chose a 3 because what are my 2 answers? A 2 or a 3. Now reflected across the y-axis. All right? Here's your answer for reflected across the y-axis. It's going to be what's called negative x on the inside. So we're going to say f of negative x. If it's reflected across the x-axis, then it would be, the negative would be on the outside. Across the y-axis, it's on the inside. So this one right here, you're going to have f of a negative x. So let's think about what f of x is equal to. Here we go. Y equals the square root of x. That's what f of x is. Now if I wanted to compress that horizontally, then that's going to change to y equals the square root of a 2x. If I wanted to expand that vertically, then it's going to be y equals 3 radical 2x. And if I wanted to reflect it across the y-axis, it's going to be y equals 3 radical negative 2x. So it looks like our answer is J. Okay? Oh, yeah, it has a negative across the y. Now we're going to do this in the calculus so you guys can see it. Okay? So right now, I'm going to clear this out. I'm going to hit y equals. We're just going to start. Everybody, we're just going to start with the regular square root of x. We're going to take that. Just regular square root of x. Take graph. Take a look at that. Now, if it's compressed horizontally, all right, what's going to be happening? It's going to be moving away from what? Away from the y-axis. You're compressing it down. So if I say y equals, and I'm going to do the next one, I'm going to say y equals the square root of 2x. Look what happens. It's going to get further away from what? Yeah. So, I'm sorry, going away from, compressed horizontally, going away from the x-axis. Expanded means going towards, compressed away. So right now we're going what? We're going away from the x-axis. Now if I say, down here, we're expanding it vertically, this should get closer to the y-axis, right? Get closer to the y-axis. And it does. It gets closer to the y-axis from the original position. And then what did I want it to do? I want it to reflect where? Across the y-axis. So I'm going to go down to the last one, which is green here. I'll type that in. 3 radical negative 2x. Hit graph. And what happens? It goes across the y-axis. Okay? So here, this was your original function. Here, this was compressed horizontally, all right, which means it's going away from the x-axis. Here, it's expanded vertically because it's going towards the y-axis, and the green one is where it was reflected across the y-axis. So those are the 3 things that were happening. So I'll highlight it real quick. Here's your compression. Here is your expansion. And here is your reflection. And I'll slide over just a little bit. There we go. Okay? Compression, expansion, reflection. All right, moving forward, right here, problem number 13. It says, what translations occur in this graph right here? So the original graph was h of x equals the greatest integer of x. So what happens when it says h of x goes to x plus 9 minus 5? So we have two parts. We have the part that happens right here on the inside, and we have the part that happens right here on the outside. So here's an easy one, okay? And here, this deals with what's called a horizontal translation. So whatever happens here is going to be horizontal, all right? Right here, this is what deals with a vertical translation. So without even doing a whole bunch of work, what do we know is happening vertically? We know it's going down how many units? Going down 5, right? So right now, I'm going to eliminate up 9. Up 9, and I know I'm dealing with what? 5 units down. Okay? So now we have to figure out, are we going to the what? Are we going to the right, or are we going to the left?
Left would be negative, right?
Yeah, left would be negative. What number? What number would you have to plug in there to make this equal to 0? Negative 9. So negative 9 plus 9 gets me to 0, so that's going to go what? Left 9 units. Like, but Mr. Moon, it's totally confusing. I see a plus 9 and I think what? I think right. But you got to figure out what number right here plus 9 gets you to 0. Negative 9 plus 9 gets you to 0. Now, let's say, clear these out real quick. So right now, let's just take a look at the greatest integer function. I'm going to hit math, right arrow, number 5, just like we've done before, and hit x. Okay? There's your original function. You hit graph. There it is. All right? Then you go, you know what? I'm just going to type it in and see what happens. So I'm going to go, whoa. I'm going to go that far down. All right, here we go. I'm going to go math, right arrow, number 5. I'm going to type in an x plus a 9. And that's it. Because I know it does what? I know it drops down what? 5 units. But if I say x plus 9 and hit graph, was that moved to the right or was that moved to the left? So you can use your graphing calculator even if you forget. You can type it in and see what happens. Investigate using your graphing calculator. So yes, that's a shift. 9 units to the left. Right. Number 14, this is a gimme. It's a gimme because literally all you have to do is type that in and look at the graphs. So, let me show you how to type it in, or you guys are doing that? Yeah, everybody's good. So if you're watching the video, sorry, we're not going to tell you that the absolute value bar is alpha window inner. Okay, not going to tell you that. All right, but alpha window inner could help you get those absolute value bars if you need them at some point in your life. All right, especially when you see Satan. If you do, put some absolute value bars around it. All right, moving on. Because even he can't resist the power of absolute value bars. Not even him. Yeah, I'm talking. All right, so here we go. That's a lot to write. So here's all I want you to write right now. I want you to write this. And I want you to write this right here. That's it. Write those two, please. Okay? I'm going to go f of x equals x over x minus 3. Okay? And then we have g of x equals 2x minus a 1. Okay? And what are we trying to find right now? We're trying to find f minus g of x. So upon first inspection, you're like, okay, I got this. I'm going to take f of x, which is this guy, all right? And then I'm going to take away g of x, which is this guy. But unfortunately, this right here does not have the same what? It does not have the same denominator. Come on. All right. So if it doesn't have the same denominator, that means what does this denominator have that this guy doesn't have?
You gotta multiply that side by x.
Yeah. So unfortunately, we've got to take x minus 3 and multiply it to 2x minus 1, which requires you to do the what? FOIL method, that's right. Sorry, I had a little audio problem right there. Apologize. So here we go. Let's get this FOIL method just taken care of. But here, 2 times x, 2x squared, 2x times negative. What's negative 1 times x? Just sign? Negative x. Negative x. Chassis. What's negative 1 times negative 3? Here we go, everybody. We've got a 2x squared. We've got a minus a 7x plus a 3. That's what all of this bad mamma jamma right here, up here, equals. Okay? So I'm going to rewrite what we have. Here we go. I've got an x minus a 3. Okay. Oh, sorry. That's the denominator. Sorry. Got x over. Thank God for erasers. X minus 3. Don't forget. Minus. Okay. Then over here in this one, put what I have in the numerator. Here we go. 2x squared minus 7x plus a 3 all over an x minus 3. Now, when you take away all of this, that means you have to take away all of it. So what's going to happen to every single number inside of here? It's going to become the what? The opposite of what it was before. If I take this negative and I distribute, say, I got to take away all of those. All right? So right now, all of this is over what? It's over an x minus 3. So what do we have? We have a negative 2x squared. We have a x plus a 7x. What does that give us? We've got an 8x minus a 3 all over x minus 3. So now, done a lot of work. We're going to go back up and see if we have anything that matches that at all. Thank goodness gracious, googly moogly. All of that work. There it is. Thank God. By the way, how fast did I try to rush through that sucker? No, I tried to take my time, go through the steps. By the way, your problem will not be that difficult, but you will have to do some type of operation. Okay? But it's not going to be as difficult. It'd be a heck of a lot easier had I just put what's x minus 2x minus 1. Okay, it'd be a lot easier. But right here, this right here was your final answer. All right, here we go. All right, here we go. Here we have a cone that has a fixed height of 10 inches. So there's 10 inches right there. It's shown on a computer screen. An animator increases the radius, r, at a rate of 3 inches per minute. Which of the following gives the volume, v of r, of the cone as a function of time? So this volume is going to be a function of time. So automatically, I think my answer is going to be F or G. All right, because it's going to be a function of time. It's not going to be a function of the what? Function of the radius. You see how this is being r squared over here, and this is t squared over here. All right. So right now, it says assume the radius is 3 inches at t is 1. This right here, everybody, this is the formula for the volume of a cone. 1/3 pi r squared h. You'll notice that right here, my h value is 10, so I plugged it in. When you plug it in, you get this formula right here. The other formula is a function of time. So I put 3t. Why did I put 3t? Because every single minute, what happens to the radius? It increases by what? 3. So what I want you guys to do is I want you to take this right here and plug it in. Because the radius is increasing, right? So right now you're going to take this and plug it in right in there. So we're going to take v of f of t, and we're going to plug it in. So we have 10 over 3 times pi, and I'm going to plug in this. I'm going to put a 3t, and what am I going to do? I'm going to square it. So what is 3t times 3t? What is that equal to? That's equal to a 9t squared. What is 9 times 10? 9 times 10 is 90. 90 divided by 3 is 30. 30 pi t, small t squared. So v of f of t, because we wanted to make a function, right? That was a function of time, not a function of the radius, but a function of time. So it looks like our answer is G. Okay. That's your answer. All right. Number 16 was a difficult problem. Number 17 is not going to be that difficult. We have two functions. We have f of x, it's given it to us, and we have g of x right here. This one says f of what? We got to find f of g. Now what does that mean? That means you got to take g of x and plug it into what? F of x. So if f of x equals x squared plus 1, what is f of g of x equal to? What am I going to put right here and square it and then add a 1? What do I have to put in right there? A 1 over what? 1 over x. Well, what is 1 over x when you square it? What does that become? That becomes 1 over n x squared. And what do you have to add to it? You have to add a 1 at the end. Does anybody see 1 over x squared plus 1?
Oh, yeah.
Anybody see it anywhere?
Yeah.
What? See? There it is. That's what you get when you take one function and you plug it into the place of the other. So that one didn't take that long, did it? You just take one and you plug it into the... By the way, if there is a difficult problem, I will at least help you get it set up and let you guys finish it. Okay? All right, the last three will be in the very end of the next video.